Hey all, welcome back to another video. Today's first question is, what is the units digit, ones digit, of the product of any 6 consecutive positive integers? So first of all, y'all know that the units digit and the ones digit of any number is going to be either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can have any one of these 10 numbers as your ones digit, okay? Whichever one you prefer, okay? So it's asking specifically of any six positive integers. And that's actually for a very good reason, because it wouldn't work otherwise. So thinking about this, I'm going to go straight forward, no use beating around the bush, and say that in any 6 that you want to choose, there's always going to be either a 0 or a 5. So either a 0 or a 5. And that is not my answer for this problem, by the way. I'm going to make this smaller so you guys don't think so when you come back to look at this. So it's going to have either a 0 or a 5 in any 6 you choose. And remember when you get to 9 and you have to cycle back over to 0, 1, 2, 3, 4 again? Because remember, this is the ones digit. But you guys can pause the video and try this for yourself. Just try any 6 consecutive. It's always going to have a 0 or 5 just to prove my point. So anyways, continuing. Since you know that 5, if you want to make a 10 with it, which would automatically give you a 0. If it includes 0, the 0 is just easy game, because then you just add a 0 onto the end. Fair and square. But if you have 5, what do you do? Because if you go 1, 2, 3, 4, 5, 6, well, I don't have a 0, then what do? You just need 5. You need to pair it with an even number. And since an even number is always going to be a multiple of 2, it's always going to have 2 in it, you can make a multiple of 10. If I chose 1, 2, 3, 4, 5, 6, then you could either pair 5 with 4, 6, or 2. Any even number in that arsenal will work. So that way you can create a multiple of 10 that has a 0 at the end, just like if you had a 0 in it. Then you just add that 0 to the back of the number, and then you would get a number with a 0 at the end. It works with anything, because since we are working with ones digit here, even if you go into the hundreds, it would still have all these 10 numbers as their ones digits. Just cycles back over all over again. So the units digit of the product of any 6 consecutive positive integers is always going to be 0. So problem number 2, what is the smallest prime factor of 11 to the power of 7 plus 7 to the power of 5? So this one is a little bit more complicated. It's playing with odds and evens here. But if we're thinking about it that way, what is the smallest prime factor of 11 to the power of 7 plus 7 to the power of 5? What do you guys notice here, okay? So you can immediately notice that 11, 7, 5, and 7 are all odd. So you guys know that if you have, my smart viewers, they know, an odd plus an odd is always going to be even. But an odd times an odd, you guys might not know this because it's relatively testing out. It's always going to be odd because it's an odd number of odds. For example, if you went odd times odd, any odd numbers, then it would be odd plus odd plus odd plus, scroll over a little bit, odd plus plus odd. And there are an odd number of odds. And since there are an odd number, then that would be odd plus an odd is an even, but there are not an even number of odds. Then this eventual situation, sorry, I don't even know what happened to OneNote then, but odd plus odd would then be odd again, transferring it back to the original. So since there is an odd number here and there are not an even number of odds, this equation is also odd. So taking that idea into consideration, that was a lot of odds. This one is more of a multiplying a bunch of the same odds together. So how does that work? So since we have 11 here, that equation would basically equal 11 times 11 times 11 times blah 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 times 11 again. And there are 7 of these bad boys. So if we're taking that idea of the odd plus odd again, we can see that each of these numbers are an odd times odd. So like 11 times 11, that is just one of these odd times odds. So you know that that would also be odd. Since following the idea from above, this is basically our first odd times odd. And since multiplication is commutative, it doesn't matter which odd times odd you do. It doesn't really matter anyway because they're all 11s. But now that you have an odd number, since 11 times 11 would be odd, then you can group on another odd number, but that's still an odd number of odds. So then you would get an odd number again. So this is an odd number, then this is an odd number, and then more odd number, and then keep grouping it until you have all 7 11s contained. So like odd, all the way to the last 11. And it's the same idea with 7, and since 7 is also to an odd number power, so 7 times 7 times ... times 7. There are 5 of these. It's this is an odd, then another odd, then another odd, and then another odd until you get to the last 7. But now that we're found that idea, what does this do for the problem? What is the smallest prime factor of these two? We don't even know what the numbers are, but we don't need to. Because now that we know that 11 to the power of 7 is odd, and 7 to the power of 5 is odd, and what I just said at the very beginning of this problem, odd plus odd is even. If you add these two together, an odd times plus an odd is even. Any even number smallest factor that matches the criteria that I just said is 2. And since this number is also even, it is no exception. So yeah, that's the end of this video. I hope you guys enjoyed. That was a little bit of a longer one. And I'll see you guys on the next one. Bye!